In the near future, some developers will get replaced by an artificial intelligent agent or some neural network. But we don't want to lose our jobs. Yeah? This is why we need to practice our skills. But we need to practice non-trivial skills, yeah, that couldn't be automated. We will not practice lead code because lead code is quite automatable. Yeah, we will try to solve real-life software problems, complex ones that touch multiple different layers of software architecture, and train on them. So currently we are training on Node.js source code. So it's open source repository. It has a lot of issues. We took one issue and tried to solve it. This is like a really cool issue because it touches multiple software layers, from JavaScript to C++ to C, and even run tests with Python, lots of different languages. We're trying to update JavaScript, apply a change state function to accept this onConfig argument, this lambda. And this lambda should be passed to SQLite C library, and everything should work fine. While we have configured our C++ environment, we encountered a lot of problems. For example, our dependencies would not resolve in our IDE in NeoVim. But we solved it with Bear. Bear come and help us and produce compiled commands JSON. Then we compiled like our debug build and try to put some breakpoints inside the C++ layer and run our JavaScript tests. So JavaScript tests need to call like Node.js C++ frameworks that will call SQLite library. But our C++ breakpoints didn't work. Somehow they didn't work. But I found the issue and actually discussed it with guys on with the core Node development team. And we found it, and today we'll try to continue. And our main goal today is to connect our debugger in our IDE so we can catch breakpoints and explore the code. And then we can deliver this feature, and then we will train our skills, and we will not get replaced by artificial intelligent agent. So let's do it. As usual, I will give myself 45 minutes because I have daytime job and I don't have a lot of time to practice. So let's begin. So during discussion with the Node Core JS team, I found that I can put breakpoints, but I can put them not in every place. I can put them only in main function. So this is Node.js, yeah? Node.js has a main function in main CC. Yeah, like this, in the main CC. So this is main. This is the starting point of any Node.js when you run your backend server. It's here. So here breakpoints work fine, yeah. But when we put your breakpoint inside Node.js function inside like internals, it doesn't work here. The issue was that when I run tests, when I run JavaScript tests, yeah, this JavaScript test need to call apply change state function and will go to C++ layer. So when I run tests, Node.js in background actually spawns a child process. So my debugger was not auto-attached to this child process. This is a common issue on macOS with LLDB debugger. So the LLDB debugger could not auto-attach to child process. This is kind of sucks, but while discussing with guys and with rubber duck method, we found that by triggering some flags, we can actually ask Node.js not to spam child process. Yeah, and everything should work fine right now. So let's check it. We will run our LLDB like this. We'll copy this, guys. And this magic command do something magic. So it slash LLDB. LLDB is debugger. This debugger will run Node.js compiled in debug mode. So everything should be debuggable. Then we can pass some arguments to Node.js. We will pass this flag. This flag will actually prevent Node.js from running a useless child process. And we ask to run this test file. This test file is this test file. This test file is this tests. There is apply change state function. And this apply change state function should call this one in C++. Pretty straightforward. So we run this. We attach the debugger, but now we need to put our breakpoints. And I have something prepared. Not SQLite. Yeah, this line. So we put breakpoint on 769 line. This is like 769. It's here. We put our breakpoint here. And when we run our Node.js, we actually hit this breakpoint. Hooray! But As you can see, applying breakpoints via LLDB is quite inconvenient because we need to like type it, like we need to type B and then the full address. And this guys is like out of our IDE. It's like separate window. So while LLDB is quite powerful, no one, I think someone uses it, but preferably you need to use your IDE that will trigger your LLDB under the hood. For example, your Visual Studio Code uses LLDB under the hood. Did you know this, guys? And my NeoVim should also use LLDB under the hood. But we need to configure it. We need to actually configure it. Let's configure it. So I started my LLDB configuration. Basically, I want to make launch Node.js debug script. Debug. By the way, have I started my timer? Have I started my timer? Yes, I have started it. Okay. And we will ask LLDB. We'll ask LLDB to launch our Node.js, and we need to pass some arguments to Node.js. What arguments we need to pass? Let's check. Yes, stop. We need to pass this one. This one is important. We don't need to pass test because test spawns a child process. And the last argument is the file that we want to test, JavaScript file that we want to run with Node.js. And this JavaScript file should be dynamic. So the window I open should automatically call Node.js. For example, here I open the file this, and my NeoVim should take this path and feed it inside these arguments and run these guys. So I think it should work like this. And let's not delete it. Stop and enter. No, run in terminal. I don't know what this. I don't know what it does. But let's try this. Let's try this. So let's open our test file here and let's run new and our Node.js debug. We forgot to put breakpoint. Hold on. Let's put our breakpoint here. Once again. Nothing happens. No, guys, we actually hit our breakpoint. Holy shit. I can't believe it. It took me like a lot of hours, like maybe 2 or 3 hours to get to this point, because this child process issue is quite tricky to handle. Yeah, but now we have our breakpoint in our IDE, and it's much more convenient to trigger breakpoints here than in LLDB, because here I can like type hotkey and put like little b on the left. Yeah, you can see it. And this is our breakpoints. And now they can be triggered. But what does this give us? For example, these args, can you check what is inside this? Yeah, actually, we can inspect our environment. We can check like what these variables mean. Like, for example, this one is field. Yeah. And we have all the fields. Like, oh, holy moly, it's quite convenient. Oh yeah, this will help with developing in C++ for sure. What else we can do? What else? What else? We can step forward. Yeah. How can I show my entire stack? I would like to inspect stack. Can I do this? I should have a hotkey to inspect stack. Tab new. Do we have tab new here? Tab. Yeah. We need to find our hotkeys. There's breakpoint like this. Okay, continue over, run to cursor. Okay, this is like useful. I want to open my stack. UI. I want to open UI. TU. Oh yeah. This is quite interesting. So now we can see actually our stack and our global variables and our local variables and registers. We can see general. Yeah, we can see ARM64 registers. Holy moly! I think it might be useful. We can do assembler sometimes. Floating point registers, not interesting. Our stack from where we could code. We was code from some V8. We was code from V8. Can we jump here? No? How to jump here to V8? Perhaps we don't have V8 in debug environment. It's okay. Okay, let's explore, guys, because now we have like our debugger. Let's explore. So what I want to explore, I actually have this onConfig function that's passes lambda. So the issue in the questions we are discussing has been already solved, yeah. But I want to like dig into it and understand how it was solved. And while understanding the solution, I can actually grow and understand more about the Node.js and how it works, and then try to implement the issue myself. So this is like lambda, and I want to understand how JavaScript code, JavaScript variables get passed to C++. So here we have, what do we have here? We have some arguments. Change set argument must be, the change set argument must be uint array. What is change set? So actually here, I don't think I can see JavaScript data, because it's inside V8 and some like a lot of references to it. Yeah. So this this not this is an array. Yeah, it has something inside it, values. Yeah, it has like this. This is, so I think this is some V8 pointer to some variable. For example, for an array. I know this array itself, and we have inside some references. So this reference, I don't think we can resolve it without something more magical. We have a special LLDB implementation for Node, LL Node. It's called LL Node. What will happen if you call LL Node on this? Let's try. Can we, how to stop it? Yeah, we have stopped. Let's go to our configuration, and here we'll try to not to run LLDB itself, but we need to run LLDB node. Which LLDB node? Not LL node. Hold on a second. Let's put here. What will happen if we will run this with LLD node? Can we actually see JavaScript environments in here? Let's try. So dub new NodeJs debug. This adapter is not supported. I'm sorry, guys. We can't see like directly JavaScript in C++ layer. It would be cool, but I think it's like out of anyone's scope. It's too complicated. So let's roll back and start development. So the jump here and duck. Okay, let's run. Let's run and jump here. So what we would like to try and understand, we would like to understand how C++ is connected to JavaScript. So first of all, we can like just test if something is a JavaScript array, which is useful. But why first argument is JavaScript array? Change set. What is this? It's any. What is this? Change set. It's change set. Any session change set. Maybe this is because like all arguments inside functions is just put in one array, one big array. Maybe, I don't know. But also we try to test if we have more arguments than one, and the second argument is undefined. Okay, so this is like first argument and second argument. The first argument is the change set, and the second argument is the config, this object. Interesting. So if you have two arguments, we would like to know if the second argument is an object. Pretty logical, but why it's done like this? Why we have like this big chunk? Oh, this big chunk is performing some configuration with options, and then actual payload is here. So code has a lot of complexity, but all complexity is like how to put it, non-essential one. The essential complexity is to run this SQLite function, and everything is above is just a way, this glue that connects C++ with JavaScript. And this glue is huge. Yeah, I believe this glue is huge. Let's investigate further. So I don't know how V8 works. Let's learn. What V8 does? Why we skip this? Hold on a second. I know why we skip this. I know why we didn't get here. This is because we run the whole file. But what we need to do is run the only test in question, this one. How to only run this test? There is like test pattern argument, like here. We can copy it and jump here. So here we need to update our run configuration so it could run only specific tests, not all the tests in the file. So if we run all the tests in the file, it will be quite painful to debug because this test is not first one. It's like lots of tests above it. And we will hit all the breakpoints. We need only a single test. But how we can pass this part to this? Here we need to pass test name. But we don't have test name. And how we can get test name? We can just ask test name. But this is not like really convenient. Let's consult ChatGPT how to do it. Like, why not? ChatGPT, please help. So I want in nvim to trigger JS test with dub like this. My test is, let's show the ChatGPT the test. This. How can I automatically resolve test name from the UI? Can ChatGPT actually help us? ChatGPT actually proposed like something insane. It wants us to use a regexp, get lines. Huh. This is a cool idea. However, I can't validate myself because I don't know Lua very much. Yeah, I check this code and I'm not sure. But let's just trust ChatGPT on this one. Hold on. We can trust it. It's never like lies. Why would it's not like beneficial to him to lie? Yeah. So we have our test name. So let's try to do this. Why not? Why not? Let's try to do this. So we jump to our test and tap. We need to put breakpoints. After restart, I lose all my breakpoints. Yeah, I hit something, but what I hit? Let's continue. No, it's continue to summon lots and lots of copies of the apply change send function. Here, I press like continue and continue, and I hit this breakpoint. This means this other stuff is running. So it's not very bad, but it's annoying. Can we just like hardcore this? We can just hardcore this name. Or perhaps we can ask dub to pass it like third argument. Oh, let's try this. I call my deb with no. Deb new this. Can I pass the test name as an argument? argument here. Yes, I can pass an argument. How? How? It asks for input. Input is like don't use the regex method. The issue with input, it will like take all my screen and I can't like have it in history. So currently, like I can press. Hold on a second. Let's execute. I can press semicolon, and I have all my history of my commands. Yeah, and I can code this my command. So if the argument will be here, it will be quite convenient because it will inside my history. But what ChatGPT proposes is not this. We'll ask for input, but I want the input be like this. Let's show ChatGPT what we actually want. And put the name of the test like this one. Hold on, it's something breaking. I copied something not important. This one. Let's put it here. Yeah, like this. Yes. Okay. Okay, how can I do it? At some point, I will need to install a video card inside my house and run my local models on it, because as you can see, ChatGPT is quite slow. So if I have like a video card inside my basement, I can run like any like models I want, and they will be faster. Maybe not as smart as ChatGPT, but still faster. Yeah. I think he got to the right thing. Let's try it. So we don't need this. We need this. Undefined global variable. Why? What this variable is? The second argument of the args function. This is cool. Like this. Yeah, like this. Okay. Let's try it. Let's actually try it. So not here, like here. Let's do this. It still doesn't ask me for an argument. Let's put our breakpoint here. Why it's so complicated? Conflict with. Nothing happens. Who knew that nothing happens? We have half time. Should we continue with configuring this, or should we continue with issue? Okay, let's continue with issue. This configuration seems quite hard. I will ask it somewhere else. Let's just disable everything like this. Let's forget about it. Let's put our breakpoint. But how we can, the issue still continues. How we can run only this test? We just moved all this test in the first part of the file. Yeah, you like delete it and jump to the very top. And this will allow, this will be the first test. Oh, no. Hold on, the horses. Hold on, the horses. I remember something really cool. I can put dot and only. And now only this test will run. Am I smart or am I dumb? Let's try. Come on, man. It's actually helped. It's actually worked. Holy shit. This is why we're doing it. This is why, because before I would struggle with this configuration, try to how to resolve it. But this is not essential. We can like hack our way around, but only running this test is really cool. So now we have everything we need to debug. We can start debugging just with one command. It will run this test, and it will hit this breakpoint. And now we will on this line we'll have like 2 arguments. We should go here. And we are actually here. And the second argument is actually object. And now we come to our V8. So we know that first argument is object, and we cast it as object. In JavaScript, everything is dynamic. In C++, there is static types. So we need to cast them. Yeah. Options. What can we see in these options? Location. We only see thumb pointers. Yeah, we don't see anything interesting. Like for example, here you can see it's like on conflict lambda, but we can't see on conflict lambda in this layer because everything is pointer, and these pointers don't resolve in my debugger because they're like strange pointers. Okay, nevertheless, what is this one? We take context in on conflict string. Yeah, this one. So we register this on conflict string inside this huge table. I don't know what this table does. Strings pre-isolated primitives for environment proxies them for the sake of convenience. String are pre-isolated primitives. So we create some pre-isolated primitives before running our Node.js, and there is like some string. What this macro does? What is v? I don't know what this v is. Holy moly, this is some v. V is very important. But what is v? And in C++, it's quite hard to see. V is argument. Hold on a second. V is argument that passed here. Yeah, in C++, it's quite hard to understand from where everything comes. Yeah, for example, I go to definition of v and I don't see it because it's macro, and macro like magic. And here I can see visually it comes from here. Yeah, but it's quite inconvenient. So for example, in JavaScript, yeah, you can see all your imports here. At least you know from which everything is imported. But in C++, it doesn't work like this. In C++, everything is magic. No, except macros magic. Yeah. Because everything is linked in one huge file. Okay, v is something we pass, and then we call 2 arguments. So basically what this does, it just takes this and call these arguments. Like, this is so strange. Hold on, horses. I don't understand this. Where can I find this? Who uses pre-isolated primitives? Who uses them? There's several places, env ash and env inline ash. Okay, for example, env ash. What did they actually do? VS. VS. What is VS? VS is another macro. And VS is take 2 stuff. And one stuff is string. And one is V8 string, and next one is property name. So we pass this. V and string goes with property name. This magic is really interesting. I wonder, can I somehow see how these templates resolve in real time? For example, these macros, because currently it's not trivial to understand what this macro should actually do. Where we are? We are inside. We are inside. Environment class. Yeah, we're inside this class, and these guys mean only created fields to this class. So basically, we create some field on conflict, and then we can like just call it and get our variable. Okay, So this is somehow just like some constant string. This is all this thing does. I don't know why they make it via macros, because it's confusing. But this is just like some constant field on environment. Yeah, you can see a lot of stuff here. CPU, but we can't see our on conflict string. Cannot evaluate. Interesting. So here we can't see. Okay, it's why not? And well, okay, what's next? This is some constant. Again, I think this is just v8 string, nothing special. This is some context. I don't know what context is. What is v8 context? Let's check. What is v8 context? Okay, v8. v8 context. So whatever, it's some context, new isolated. Perhaps everything lives inside this context, like a huge container. What is options? Options is our object. So we can take from object, and then we pass several arguments to lockout checked. We actually need to research this. I need to understand how v8 works. So maybe I need to read some v8 onboarding tutorial. Getting started with embedding v8. Okay. v8 tutorial, C++. How much time we left? 14 minutes. v8 embeddings. I'm not running embedding programmer. I'm not doing this. Objects. Okay, let's try ask ChatGPT. Let's try ask like this. Maybe it will help us. Okay. I wonder. Options is a JavaScript object. On conflict is a v8 string. We want to get data from the object with key. However, I don't understand why get needs context as the first argument, and what does ChatGPT is just dying on me. Nevertheless, we can look like here. Maybe we can find here get. Okay, we get not with braces. No. Documentations. Let's jump here. TTT stability committer debugging embedding under the hood tools. Committer. We need some tutorial. Creation build. No. Okay. Wait, operations are executed in the context of specific JavaScript environment. The context provides information about current scope, including bindings, prototypes. Okay. When you call this, context ensures the correct JavaScript execution environment is used to resolve this. But can this like resolve from options? No. Without know how to properly cross. To lockout check convert maybe later to local, but only if value exists. Maybe local is used to represent operations that might fail. To lockout checked asserts that maybe local contains the valid variable. To lockout checked. So there's like maybe some operations could fail. Local check, interesting, very interesting. So perhaps everything needs context to execute in V8. Why not? I thought it could take it from options, but it couldn't take from options. Yeah, from where we get options? From args. From where we get args? From here. From where we get context? From env. From where we get env? We got env from args, and we got options from args. So they both come from one source. And perhaps options could knew that they have context, but somehow we need to pass context from like above. This is frustrating. Nevertheless, let's continue. As usual, I can't understand anything JavaScript here. Conflict value. So we're just testing if it's defined or undefined. If undefined, we'll do something. It's undefined, but I know it's defined. Hold on a second. It's undefined. So it's not undefined, it's actually defined. Okay, we check it's defined. This is actually Lambda function. We check it. What's next? We cast it to the function. Can we just cast it and check the cast has failed? Why we need to check it like this? I don't know. It's V8. We actually create our Lambda and bind some variables to this Lambda. We bind environment and we bind the Lambda. Okay, let's continue. So we have our Lambda. This Lambda is global. The reason Lambda function needs to function pointer. Okay, whatever. This is std function. Yes, this is really C++ function. Lambda. We made a Lambda, C++ Lambda from JavaScript Lambda. How to call JavaScript Lambda? To call JavaScript Lambda, we just pass context, because everywhere we need to pass this context will be quite frustrating for us, and some arguments. Isolate, env isolate, integer new, env isolate. Let's conflict type. Now I am interested in what isolate is. What env isolate is. And turn us our V8. We need to find V8 tutorial for sure. V8 is quite complex, but knowing V8 is, I think, is fun. It's some virtual machine, JavaScript virtual machine. Why not? High performant. My Chrome browser using V8. Currently, I'm clicking here. It's all V8. V8 is like backbone of our society. If you don't know V8, you don't know the backbone of our society and our internet. V8 is. I need to know V8. As current environment here, isolate represents independent JavaScript execution context. So we create like new context. In Node.js add-ons, it refers to slightly used current JavaScript execution thread. When creating V8 objects, you must pass the isolate to associate the new object with the correct execution context. So context is super important stuff. It's not quite obvious how it works. So we can like extract context from arguments. We can extract context from environment, but we also can like create new context isolated. This is interesting. We need to find the documentation of the context for sure. So isolation level. So I believe if variables live in one context, they will be executed in one thread, and so they will be like thread safe. And something related to garbage collection. So this is how we create different objects. So like how check resolves, maybe Lambda or maybe monad, and yeah, but what is the difference between like I don't understand what the difference between this one. What is the difference between and What's the difference? Do they have similar types? What is type is this? This type is v8 context. Hooray. What type is this? This type is v8 is LED. It's two different concepts altogether. ChatGPT is dying. Nevertheless, we need to find the tutorial on v8 and understand context and the LEDs. And this is like will move us forward. Currently, I see how to create integers, how to call functions, how to get arguments from a function, how to work with objects, how to extract constant strings from a global environment, how to resolve maybe monad. Yeah, what get returns us. Get returns maybe local, yeah, maybe monad, so we can resolve it. This all stuff is very cool, but and I can understand it. I can understand this. I can understand everything, for exception of context and isolation. There's some really fundamental concepts for our internet, for our browsers, for our devices. This is like a backbone of our web society, context and isolation. And I will need to understand them, okay? Nevertheless, we created our Lambda, put it in global C++ Lambda, no, not Lambda, but function. What's next? Filter string. We don't have filter string in our options. Yes. Yes, we don't have filter string in our options. It's okay. Hold on, what's this? This is like options ended, yeah? Yeah, options ended. And now we just want to run our change send function and collect some output. Array buffer, what's this? Array buffer provides access to array buffer view storage. Is this like from Node.js? Yes, this is something from Node.js. So is this like Node.js array buffer? And we put first argument there. As the first argument is our change set. So, but this doesn't need context. So what it does is basically extracts change set from the first argument as array buffer. Yeah, this is our change set. And our change set is just some binary comments. Yeah. Our change set is from here. Our change set is some insertions, some table creations and insertions. So this is like SQLite commands, in raw form. Never seen them before. Quite fun. Quite intriguing. Connection. We have some connect. Where is store connection? Where do we store connection? Our args this. So our args has this pointer, and this pointer from our args is database 2, and database 2 has the connection, the private field connection, and this is like SQLite connection. Buffer length, and we just directly feed this command inside our SQLite. What does this? Some casts, static casts, const casts. Okay, we just cast to void. Everything we've done, we just cast to void. Yes, just we cast to void pointer, and this is a signature pointer, so cast to void pointer. Do we really need to do this? Can we just like this? Yeah, somehow we need to void pointer. Okay. What's filter? Filter is not defined right now. No, it's defined. Okay, but we haven't. The filter is defined. Filter is actually defined. Okay. Conflict. What is conflict? Conflict is a function that will call our global defined lambda, but it's not defined. We just return an error. straightforward. And something else, and let's run it, blah, blah, blah. And we have 0 is okay. Then return value. So we have not in this argument, we not only have our this pointer, not we only have our environment, not only have we our arguments like this, yeah. There's like overall like from index, from 0, index 1, index. No, we also have here return value, and we actually can set, and this will pass to JavaScript. Huh. And this will pass to JavaScript. I'm starting to understand everything. How much time? 30 seconds. Okay. So everything works fine. Hooray. What we need to do, we need to understand how context and isolation works in the V8. V8 is backbone of our society. It's really cool to know V8. So next time I will prepare some documentation, maybe read something beforehand. And if we understand V8, context isolation, we can actually write this function ourselves. Well, at least try to write this function ourselves, because there's a lot of details there. Once again, thank you for your time. If you like my comment, please give a like, subscribe, and I see you next time. Bye.